We take the same numbers as from the previous lesson. That is, VB with respect to r is 5 meters per second. So we intend to move along the line AB with a speed of 5 meters per second. And the river current, or VR, is 3 meters per second to the right. This time we want the boat to travel through the shortest distance between the two shores, which would be along the perpendicular. So the aim is to get the vector VB, or the velocity of the boat with respect to the ground, to be perpendicular to the banks of the river. A stationary observer will see the boat moving along this line. Now what should be the angle phi that the boat should head out in? In the previous problem, we dealt with the case of minimum time, in which case we pointed VB with respect to r perpendicular to the river bank. But this is a case of the shortest distance. So here we have to point VB perpendicular to the river bank. From geometry, we have sine of phi equals VR over VB with respect to r. So phi is the sine inverse of VR over VB with respect to r. And from here we get phi as 37 degrees. So the boat should head out making an angle of 37 degrees with the vertical in the anti-clockwise sense. And that would mean an angle of 90 plus 37 with respect to the x-axis in the anti-clockwise sense. And when its intended direction is along line AB, the current will make it reach point C, right opposite across from point A, and this would be the shortest distance. Now let's find the velocity of the boat with respect to the ground as seen by a stationary observer. These three vectors form a right-angled triangle, with vector VB with respect to r as the hypotenuse. The vector VB would be the square root of 5 squared minus 3 squared, which is 4 meters per second. So while the boat is being rowed at 5 meters per second along the line AB, a stationary observer on the shore sees the boat moving along the line AC at 4 meters per second. Let's find the time taken to move across the river in this case. Now let's just focus on the y-axis. The displacement is d, or 100 meters. The velocity Vb is itself along the y-axis, so we need not find any components. Therefore, the time taken would be 100 divided by 4, which is 25 seconds. And if you refer to the previous lesson, you will see that when we took the path with the shortest time, it took us 20 seconds. Whereas if we take the shortest path, it takes us 25 seconds. So the shortest time does not guarantee the shortest path.